Hello everyone, as you all know that myself I'm Gangotri studying in SPCE Bengaluru. Today I'm going to explain the topic of applications and uses of integrals in real life. Importance of integrals. An integral is a function of which a given function is the derivative. Integration is basically used to find the areas of two-dimensional regions and computing volumes of three-dimensional objects. Therefore, finding the integral of a function with respect to x means finding the area of the x-axis from the curve. Integration is the workplace allows system to work together efficiently, elevating productivity and leading to more enhanced data consistency. Integral equations are important in many applications. Problems in which integral equations are encountered include radiative transfer and the oscillations of the string, membrane, or axle. Oscillations problems may also be solved as differential equations. Integral calculus is a primary mathematical tool in engineering, essential for solving problems that involve summation and accumulation of quantities. It's used for calculating area, volumes, total quantities, and for solving differential equations. Applications of integrals. To find the center of mass, centroid of an area having curved sides. To find the area between the two curves. The area under a curve. The average value of a curve. Applications of integrals. There are many applications of integrals, out of which some are mentioned below. In maths, to find the center of mass, centroid, to find the area between two curves, to find the area under a curve, the average value of a curve. In physics, integrals are used to calculate center of gravity, mass and momentum of inertia of vehicles, mass and momentum of satellites, mass and momentum of a tower, the center of mass, the velocity of a satellite at a time of placing it in orbit, the trajectory of a satellite at the time of placing it in orbit, to calculate thrust. Like in the field of engineering, engineers use integrals to determine the shape of building constructions or length of power cables required to connect the two substations, etc. In science, it is used to solve many derivations of physical and physics topics like the center of gravity and etc. Area between the curves, distance, velocity, acceleration, value, average value of a function, work, center of mass, kinetic energy, improper integrals, probability. You can use specific integrals for finding the area under a curve. You can also use them to find the area between the two curves. To find the area between the two curves defined by the function, integrate the differences between the functions. Definite integrals can be used to determine the mass of an object if its density function is known. Work can also be calculated from integrating a force function or when counteracting the force of gravity as in pumping problem. Estimating the area of the curve, evaluation of double and triple integral, curve tracing and calculation of area of Cartesian and polar curves, estimation of the length of the curve and in finding the volume of revolution about the axis. Application of integration as four standard levels, that are, first one is presentation level integration, second business process integration, third one is data integration, fourth communication level integration. Working in machine learning, we some need to use integration to do our work more easily. Mainly, integrals are the inverse of derivatives. More importantly, Using integration provides a way to compute the area under the curve of almost any function. Application integration is the merging and optimization of data and workflows between two disparate software applications. Often, a new cloud application with a legacy on-premise application. AI integration empowers businesses to extract actionable insights, automate repetitive tasks, and help in the decision-making process. Consider the integration of AI into existing systems if you want to ensure scalability and enhanced efficiency in your current business workflows. The idea of integration is to find an equation for an area under a curve. It can be expanded to the area between curves. Volumes are a range of equivalents across almost any area of numerical study. At a very basic level, one example of calculus being used in statistics involves integrating over sections of a probability distribution. This will yield the cumulative probability over those values, which is simply the area under the curve. Integration is a better fit for nowadays lifestyles. Balance means things could go one way or another. It means one side will always prevail because perfect balance does not exist. It also means you are always shifting it in the unstable situation. Data integration plays a crucial role in enhancing the performance and accuracy of machine learning models. In today's rapidly evolving digital landscapes, businesses and organizations are constantly generating vast amounts of data from various sources. Integrals are utilized in variety of sectors in real life, including engineering, where the engineers use integrals to determine the geometry of a building. It's used to describe the center of gravity, among other things. In physics, in the field of graphical representation, three-dimensional models are displayed. Integrals in economics are used to calculate consumer and producer surplus by integrating the demand and supply curves respectively. Consumer surplus in the area between the demand curve and market price, whereas producer surplus is the area above the supply curve and below the market price. The resulting integrals are used to determine the ratio of hydrogens that are corresponds to the signal. The HNMR spectrum of CH3O CH2Cl shows two integrals that are shown. However, for those who want to get into prediction modeling and hypothesis testing, integrals are the fundamental building blocks to being a data scientist. It will be extremely useful to know the basics of integration if you plan to learn about the statistics and probability distribution in greater details. Thank you.